Hi, everyone. We are on 7.4, day 6 notes. We are going to continue proving trig identities. So make sure that you review all of these helpful hints and steps that we are going to be doing to solve these different trig identities. And also make sure that you take a look at those basic trig identities that we wrote on the top of our sheet yesterday. So our first example is number 10 from the textbook. We have cosine of theta over 1 minus sine of theta is equal to 1 plus sine of theta over cosine theta. Okay, so both sides kind of look equally difficult, but we are going to work with the left-hand side. I am going to notice that 1 minus sine of theta, if I had 1 minus sine squared of theta, that equals cosine squared theta, which gets us a little bit closer to the denominator of cosine of theta. So what I'm going to do is multiply the top and the bottom by the conjugate, which would be 1 plus sine of theta. So cosine theta over 1 minus sine theta times 1 plus sine theta over 1 plus sine theta is equal to 1 plus sine theta over cosine theta. Okay, now when I multiply this out, I want to end up having 1 plus sine theta in the numerator, which we do have that right here. So instead of distributing the cosine of theta, I'm just going to leave it as cosine of theta times 1 plus sine theta. So hopefully we can cancel something out eventually. And then I have 1 minus sine squared of theta, and that equals 1 plus sine theta over cosine theta. Okay, now from our identities that we wrote down yesterday, 1 minus sine squared of theta does equal cosine squared theta. So I have cosine theta times 1 plus sine theta over cosine squared theta is equal to 1 plus sine theta over cosine theta. Okay, now I can go ahead and cancel out my cosine of theta with my squared in the bottom, and I will end up with having 1 plus sine theta over cosine theta is equal to the right-hand side, which was 1 plus sine of theta over cosine theta. Okay, number 58, we have 1 minus cosine of c times 1 plus secant of c is equal to tangent of c, sine of c. So here I can see that the left-hand side is using some addition and subtraction, so that's going to be the more complex side. So the first step I want to do is to FOIL or double distribute. So when I do that, I end up with 1 plus secant c minus cosine of c minus cosine of c times secant of c is equal to tangent c sine c. Now I want to rewrite this only using sine and cosine. So 1 plus, remember that sine or secant is going to be 1 over cosine, and then minus cosine of c, and then again let's change secant to be 1 over cosine. Okay, now I should be able to see that this cosine c times 1 over cosine c will just cancel out and become a negative 1. So I have 1 plus 1 over cosine c minus cosine c minus 1 is equal to tangent c sine c. Okay, then I've got a positive 1 and a negative 1, so let's cancel that out. So I've got 1 over cosine c minus cosine c equals tangent c sine c. So if I want to subtract here, I need a common denominator. So let's multiply our cosine of c by cosine c over cosine c that we have, so that we have a common denominator. So I have 1 divided by cosine c minus, I'm going to have cosine squared c over cosine c. Okay, let's go ahead and write that as one fraction. So I have 1 minus cosine squared of c over cosine c is equal to tangent c sine c. Okay, now let's recall that 1 minus cosine squared is the same thing as sine squared. So this is going to give me sine squared c over cosine of c is equal to tangent of c sine c. Okay, I'm running out of room, so I'm going to move over a little bit to the right-hand side. So this is going to be sine of c times sine of c over cosine of c. Okay, now sine of c over cosine c is the same thing as tangent. So I do end up with tangent of c times sine of c, and that equals our right-hand side. '59, we have cosecant squared of theta plus secant squared of theta equals cosecant squared theta times secant squared theta. Okay, so the left-hand side has some addition in there, so that's the side that we are going to change. So let's rewrite this only using sine and cosine. So I am going to have 1 over sine squared theta plus 1 over cosine squared theta, and that is equal to cosecant squared theta and secant squared theta. Okay, now if I'm going to be adding fractions, I need to have a common denominator. So I want to multiply this first fraction by cosine squared theta over cosine squared theta. And I will multiply this second fraction by sine squared theta over sine squared theta. Now that'll give me my common denominator. So if we do that, we have cosine squared of theta over cosine squared theta sine squared theta plus sine squared theta over cosine squared theta sine squared theta. And that again equals cosecant squared theta and secant squared of theta. Okay, now let's go ahead and add this. Cosine squared theta plus sine squared theta over its common denominator. Okay, now if we recall from our basic trig identities that we wrote down yesterday, cosine squared of theta plus sine squared of theta equals 1. So I've got 1 over, now cosine, remember, goes with secant, sine goes with cosecant. So I'm just going to rewrite this as sine squared theta, cosine squared theta. Okay, and I can also write this as 1 over sine squared theta times 1 over cosine squared theta. Okay, and then 1 over, oops, I meant to highlight that. 1 over sine squared theta is equal to cosecant theta, and 1 over cosine squared theta is equal to secant theta. So my last step, just rewrite that out. And then you are done. Number 64, we have cotangent squared of A minus tangent squared of A over cotangent of A plus tan of A, that quantity squared, and then equals 2 cosine squared of A minus 1. So let's start with the left-hand side, and let's recall, we used this yesterday, that x squared minus y squared is equal to x plus y times x minus y. So let's go ahead and do that with our numerator here. So I am going to factor this out to be cotangent of A plus tangent of A times cotangent of A minus tangent A all over cotangent of A plus tangent of A. And we want that to equal 2 cosine squared of A minus 1. So to save some space right now, I'm not going to write that out. Let's just keep in mind that that's what we are working towards. Okay, so I've got cotangent of A minus tangent of A. I can cancel out my, and this has a squared on there. I can cancel out that squared with cotangent of A plus tangent of A. Okay, so now I am left with cotangent of A minus tangent A all over cotangent A plus tangent A. Okay, now I want to rewrite this using sine and cosine. So cotangent is cosine over sine. And tangent is the opposite, sine of A over cosine of A. We're going to do the same thing with the denominator. So cosine A over sine A plus sine A over cosine A. Okay, so if I lost you a little bit here, the numerator became that in yellow. We're just using sine and cosine, and the denominator became that in purple. Okay, so now I want to cross multiply the numerator and the denominator. So when I do that, I am going to end up having cosine squared of A minus sine squared of A all over cosine squared A plus sine squared A. Okay, and let's recall that cosine squared A plus sine squared A equals 1. So I am left with cosine squared A minus sine squared A. Okay, now if we remember, I am trying to get 2 cosine squared of A minus 1. So I want to eliminate my sine squared somehow. Okay, well, sine squared is the same thing as 1 minus cosine squared. So we're going to rewrite this as cosine squared of A times, minus 1 minus cosine squared of A. Okay, now if we distribute that negative, I will end up having cosine squared A minus 1 plus cosine squared A. Now I can just combine my like terms, and I end up with 2 cosine squared A minus 1, and that equals 2 cosine squared A minus 1, which was our right-hand side of that equation. Okay, number 72, we have cotangent of beta plus sine of beta over 1 plus cosine beta is equal to cosecant of beta. So let's go ahead and rewrite the left-hand side just using sine and cosine. So cotangent is cosine over sine. So I've got cosine beta over sine beta plus sine beta over 1 plus cosine of beta, and that is equal to cosecant of beta. Okay, now if I want to add these fractions together, I'm going to have to multiply by the opposite one's denominator in order to get a common denominator. So I want to multiply my first fraction by 1 plus cosine of beta over 1 plus cosine of beta. So let's do that first. So if I distribute the 1, I'm going to get, let's just leave it for now. So I'm going to have cosine of beta times 1 plus cosine of beta all over sine beta times 1 plus cosine beta. And then for that second fraction, I'm going to be multiplying by sine of beta over sine beta. Okay, and when we do that, we will end up with sine squared beta over our common denominator, which was sine of beta times 1 plus cosine beta. And we want that to equal cosecant of beta. Okay, now I can add these up. So when I do that, I am going to have cosine beta times 1 plus cosine beta plus sine squared of beta over our common denominator. Okay, now I'm just going to distribute this cosine. So I've got cosine of beta plus cosine squared beta plus sine squared beta over common denominator. Okay. Now I can see that cosine squared plus sine squared equals 1. So let's write this as cosine of beta plus 1 over sine beta times 1 plus cosine of beta is equal to cosecant of beta. Now I can actually just cancel that out, and I'm left with 1 over sine of beta, which equals cosecant. So we have proved this identity.